Hello friends, welcome back to my channel Zero Web. This is me Rikila Srijesh. In this session we are going to solve the exercise 3.4 of chapter 3, Understanding Quadrilaterals. We will see the first question. State whether true or false. In total there are 8 statements. So we have to state whether these statements are true or false. So we will see one by one. So the first statement is all rectangles are squares. We have in a rectangle, opposite sides are equal and parallel. But in a square, all the sides should be equal. Right? So we can say all rectangles are not squares. But a rectangle becomes a square only when all the sides are equal. Okay? So the statement is false. Right? The statement is false. So what is the reason? Statement A, reason you can write as it is false. The reason is in a rectangle only opposite sides are equal. But in a square, all sides are equal. Clear? So this is the reason. The second statement, all rhombuses are parallelograms. The statement is true because we have the rhombuses are the special parallelograms, right? So we can say the statement is true. The reason is rhombuses are special type of parallelograms. Right? So here the statement is true. Right? And now third statement, all squares are rhombuses and also rectangles. So here in this statement, so we can separate this as two parts. First one is all squares are rhombuses. The statement is true. Why? The reason is all squares satisfies the properties of rhombuses. Right? So in a rhombus as well as in square, we have all the sides are equal. Therefore, all squares are rhombuses. Right? Second part is all squares are rectangles. The statement is true. Why? Because in a square, all sides are equal. But in rectangle, only the opposite side should be equal. All squares should satisfy the properties of rectangles. So that this statement, all squares are rectangles, that statement is also true. Therefore, the whole statement, all squares are rhombuses and also rectangles is true. Clear? So we can write the reason. Okay, so how can we write the answer? The statement is true. The reason is all squares fulfills the properties of rhombuses as well as rectangles. That's why the statement is true. Now, the fourth statement, all squares are not the parallelograms. That statement is false because we have squares are the special kinds of parallelograms, right? Therefore, this statement is false. this statement is false. Reason is squares are special type of parallelogram. Next statement, all kites are rhombuses. Have in a kite only two pairs of distinct sides are equal, right? That is, if we are considering a kite, see, in this kite, these two sides would be equal, these two sides would be equal. But it is not necessary that these two sides would be equal, right? In a rhombus, we have all the sides should be equal. All these sides should be equal. Here in this kite, only these two distinct pairs of adjacent sides are equal. But these two are not always equal, right? So we cannot say all kites are rhombuses. Therefore, the statement is false, right? The reason is, the statement is false. The reason is, in a kite, only two distinct pairs of adjacent sides. Pairs of adjacent sides are equal. But in rhombus, all the sides are equal. Clear? Next statement is all rhombuses are kites. So this is the converse of this statement, right? All rhombuses are kites. We have in a rhombus all the sides should be equal and all the opposite angles should be equal. And here in the case of kite, we have only two pairs of distinct adjacent sides should be equal and only one pair of opposite angles should be equal. So the rhombus satisfies all the properties of kite. So we can say all rhombuses are kites, but all kites are not a rhombus. So therefore, this statement, all rhombuses are kite, is a true statement, right? And the reason is, rhombuses fulfills the properties of kites. That is the reason. Okay. Next statement, all parallelograms are trapezium. We have in a parallelogram, opposite sides are equal and parallel, right? In a parallelogram, two pairs of opposite sides are there, right? These two are parallel and these two are parallel. That is, two pairs of parallel sides would be there in the case of a parallelogram. But in the case of a trapezium, there should be only one pair of parallel sides. Right? Therefore, we can say parallelogram satisfies all the properties of trapezium. because already it is having two pairs of parallel ends. But to form a trapezium, only one pair of parallel sides is needed. Okay, so we can say all parallelograms are trapeziums. Clear? So the statement is true. The reason is, in a parallelogram, there are two pairs of parallel sides, but in a trapezium having only one pair of parallel sides. Therefore, the statement is true, right? The statement is true. Last statement, all squares are trapeziums. We have in a trapezium, there should be only one pair of parallel sides, right? In a trapezium, there would be only one pair of parallel sides. These two are parallel. But in a square, we can see two opposite sides are parallel, right? Therefore, we can say all squares are trapeziums, right? So the statement is true, right? Statement is true. The reason is, in a square, there are two pairs of parallel sides, but to form a trapezium, only one pair of parallel sides are needed. So the statement is true. The statement is true. Clear?